Hi, everybody. My name is Barry. I'm one of the co-founders of Skip.
My name is Zach. I'm an engineer at Skip, joined in December.
So Skip works on MEV infrastructure and protocols for Cosmos blockchains. We've been doing that for 9 months or so now. We have block building software that's deployed on almost a dozen Cosmos chains now, some centralized, some solutions, some decentralized solutions. We work on order flow products, generally trying to help chains recapture their own MEV. But in that process, we have also discovered that for there to be meaningful MEV for chains to be able to recapture in Cosmos, we need Cosmos to grow significantly. And we think to do that, we need to improve IBC. And that has kind of led us down this path of going from a company that is primarily focused on MEV to going to a company that thinks really deeply about incentives and infrastructure development to try to improve cross-chain UX much more broadly. And IBC Unwinding is a big part of this. So a very short story. A few months ago, we got a bunch of our investors and a bunch of other investors together to try to generate interest in and excitement about the challenges and the opportunities of building cross-chain ecosystems. Because now there's all this hype that exists outside of Cosmos for ideas that were originally developed in Cosmos. Thoughts around, oh, you know, there's going to be 1 million rollups. So we got a bunch of these investors together, and we gave them all a little bit of Ethereum on ETH. Okay, maybe I was too close to the speaker. We gave them a little bit of Ethereum on Ethereum, and we said, come to Cosmos, and we assigned each of them a chain. We said, use your ETH, get it over here, go to this chain, and do something on this chain. And a lot of them who have invested a lot of money in Cosmos projects sort of futzed around for a bit, eventually discovered Axelar, and managed to use Axelar to transfer into whatever their target chain was. And they ended up with Axel-wrapped ETH on that chain. And for a number of them, their immediate thought was, okay, I need to sell some of that for the chain's native token or for something else that I can use. And they immediately realized there was no Axel-wrapped ETH on a lot of these chains. So they said, okay, I'm going to go to Osmosis, and where there is Axel ETH liquidity, and I'm going to sell my Axel ETH. So we had to give them some gas tokens to do that, so they got stuck, and then they did that. And then they realized that their Axel ETH on Osmosis was useless because it was bridged over from Terra or from Evmos or from somewhere else, and it wasn't actually fungible with the ETH that was bridged directly from Axelar. And so here were all of these investors who've invested millions of dollars in Cosmos projects completely stuck, completely unable to use the ecosystem because of Path Unwinding. So we're going to talk about what the problem is, which is IBC token winding, and then the solution, which is obviously IBC token unwinding, and then we're going to talk about some stuff that Skip is working on, both open source and off-chain, to try to improve the state of the world. So just to be very clear about what the problem is with Path Unwinding, is when you transfer a token across IBC, you are basically stamping that token with a record of the chain that it came from. This is important for security reasons. But what that means then is that if you go over 2 different paths, you end up with tokens that are non-fungible. So in our case, we have Alice on Osmosis with Axel ETH, and she is trying to go to Terra. But if she bridges it directly, she's going to have the wrong version of Axel ETH there. She needs to go back through Axelar and then to Terra. And I just want to be clear, this is a problem that's about to get much, much worse in Cosmos. It's something that we see today, But because of a lot of exciting things that are now happening, we're going to have a lot more tokens that are being used on multiple chains where they didn't originate. So you're going to have USDC, which is always going to be originating at Noble, which is going to be used on Evmos, Terra, Osmosis, all over the place, basically everywhere, if we're lucky. But every time somebody needs to transfer it, they're probably going to want native USDC, which means it has to go back through Noble. Additionally, liquid staking tokens have the same problem. They originate at Stride, or they originate at Quicksilver, or they're originating at Neutron. And as we try to move them around, we're going to end up with a lot of different copies of the same thing. And ordinary users who aren't going to find themselves here are going to have no idea how to get around this problem. They'll just be like, I did what I thought I was supposed to do. I bridged from one chain to another. I thought I had Axel Wheath. I still think I have Axel Wheath, and I can't do anything with it. So IBC Unwinding is going to become much more important. Zach, you want to?
Yeah, so the solution that, to this IBC winding problem, we've kind of like broken into a couple different pieces. The first, well, just to run down is, first we have to get the token back to the source chain where the token was originally minted, because this is kind of like the purest version of the token. And then, and then we want to find a path from that source chain to the wherever we want the tokens at. So in Barry's example, that was Terra, and we have to figure out, the whatever the quote ideal path to that destination is, and that we run into a couple issues when trying to figure out this path, or even deciding if there's multiple paths, like which is the desired path, and then finally transferring the token to the destination, which we'll see is very similar to what we do in the first step, but with the result of what we get in number 2. So to unwind a token to the source chain, this is actually relatively easy because all IBC tokens have encoded in their denomination trace, which is essentially, the denomination trace is really just the path back to the source chain. So it's a list of IBC channels, and if you simply just recursively take those IBC channels on each chain, eventually you will end up with the native token, or the originally minted token, on some IBC-enabled chain. And if we use something like packet forward middleware, which PFM, it's fairly easy to prepare this transaction from the data that's on the original chain. The second part that I kind of hinted is like the hard part is, first of all, computing this destination path is difficult because you have to figure out, we know how to get back to the source chain from a token, but we don't necessarily have the channels that we need to actually go along to get to the destination. But aside from that problem, there's also this ideal path problem where if there's multiple paths, which is kind of the original problem that we ran into, is we tried going directly to Terra, and what we needed was the ideal path was actually to go back to Axelar and directly to Terra. And so there's kind of a couple of options for what an ideal path might look like. One is perhaps the shortest path from the source chain, and that's often the best path that you want to take. But there are situations where a token is minted on one chain, but is utilized on another chain, and then we want to trade it on Osmosis. And so it turns out that on Osmosis, the canonical token is not the one that comes directly from the source chain. It's the one that comes through an intermediate chain where the token is actually utilized more often. So other option is that we can have governance determined, but there's a question of which chain is responsible for determining who decides for which chain what canonical tokens are. And then one of the things that seemed like it would work is looking at the most liquid chain. And even in these cases, it's kind of easy to find examples where the token is the most liquid is sometimes not exactly the token that you want. Because like liquidity, is that just defined by like total supply of the token, or is that like whether or not there's a pool that exists that you can trade the token in? And it's probably highly user dependent and like application dependent. And so it seems like there's some judgment calls that have to be made on like what ideal path is for the specific user, the specific application, or this a specific chain. So ignoring that problem on how we solve it for a second, getting to the destination, just to mention this, is once we've determined a path, so we've chosen an ideal path, which is essentially a list of channels that if we just follow those channels recursively, we will find ourselves at the destination chain. We can do exactly what we did to get it to the source chain, and in fact, we can actually chain those two sets of IBC hops together with something like packet forward middleware. So one of the ideas for finding an ideal path is having like an on-chain like CNS, which you can think of as essentially a map from chain IDs that users understand to channels, and maybe having this map like updated by governance on the chain where the source is. And this actually works pretty well for a lot of tokens because a lot of tokens are only a single hop away from their source chain, and in that case, like this works. But from a user experience perspective, something working like 95% of the time or even 99% of the time is not really a solution, because the more users you have in the mix, the more often you're going to run into this like 1% case where your CNS solution doesn't work, and then users have bad experience, and then like lose trust in the system. Oh, perfect. We have pros here. So again, works great for single hop. Accessible to smart contracts. That's another benefit here, because presumably smart contracts want to participate in IBC. Yeah, and then I think there's also just a question of like if different on-chain CNSs like believe that osmosis is like a different chain, right? I think this isn't a common case, but there's I think like a chain ID is not necessarily a unique thing, and figuring out like what we mean by these things can be confusing. But yeah, there's a lot of cases where this works great.
Yeah, so I think generally we think having on-chain CNSs is a big part of the solution, but isn't the whole solution, and isn't something that's necessarily going to be accessible to wallets or application builders or front ends today. And because this is a problem that we ourselves have encountered, investors have encountered, it's something that we're trying to actively build tooling around right now. So we've built this thing called Skip Solve, which is basically an intelligent IBC pathing API. Yeah, we're trying to make all wallets smarter, basically. It offers an API for querying what an ideal route might be given a token, given a source chain, and given a destination chain. And it offers alternatives when the answer might not be obvious. It can do shortest, most liquid, whatever is enshrined when an on-chain governance enforced CNS does exist. And it provides fee estimations and timing estimations based on relayer reliability for those channels. And when it's not possible to do in a single transaction, we give multiple transactions and help wallets actually execute them on chain. They can hand us back the transactions after they've been signed, and we give them a receipt that allows them to tell their users where the transaction is at any stage. I think an important thing to note here is that on almost every front end in Cosmos today, except for on the TFM bridging application and the osmosis front end, you kind of need to know today what a channel is. And oftentimes it's even hard to figure out what channel you should go to, even if you know you should be looking for a channel. So the entire idea of this is we want to basically provide an IBC abstraction layer for everyone who is building an application in Cosmos and knows they need liquidity from other chains and need to be a part of moving that liquidity around, but don't necessarily want to get into the weeds of how all of this stuff works. So just a quick example, a wallet sends an API request to us that says, hey, I have a user that wants to transfer Axel WETH from Osmosis to Terra. How should I get there? We respond with the correct multi-hop packet, and we say, hey, warning, if they do want to do this direct one, they can do it as well, but we don't recommend it. And then we give them a receipt after they send the signed transaction back to us that they can then query to know what chain is my transaction on, has it failed, what do I need to tell the user, so they can kind of hold their hand throughout the process. We're launching V0 in 2 to 4 weeks. We've got some fun design partners who are major wallets in Cosmos who are going to be adopting this. It's totally free. We want to see more front ends give people good IBC transferring experiences. So if you have a front end, if you think liquidity might be coming from somewhere else, or you might be a part of sending liquidity to a different chain, this is something that you can integrate with as well. So come chat with us afterwards if you're interested in signing up and talking about what that looks like. So there are some unsolved problems here. A big one is IBC transfer atomicity. We put up an idea for how we could add this to the ICS 20 standard for multi-hop transfers. There was a bunch of discussion around it. It was great. I think one of the main takeaways was what exists today, which we really like, is packet forwarding middleware, but adoption is kind of patchwork. Not everybody is using it. So to solve the atomicity problem, we're going to need some upgrades to PFM, but PFM is a great start. So if you are responsible for a chain and you think people might want to use USDC on your chain or a liquid staking token, you should use PFM. And if you don't know what that is, come talk to us or anyone from Strangelove. They built it. It's sick. We love them for that. And that's basically it. That's everything I had to say. Thank you, guys.